All right, we are starting with number 13. And to start out, you just need to plot 3 points. The point A is negative 5, 4. Point B is negative 2, 8. And the point C is 5, 4. So leave yourself some space, but just put a y-axis and an x-axis somewhere on your paper and plot those 3 points. And then also connect them after you get them plotted to make a triangle. Okay, so the topic today is translation. And what we're going to do is we're going to take this triangle and we're going to move it. Well, on this one we're going to end up down here, but a translation could go in any direction. It's just sliding the figure from where it is to a new location. And when you have a translation, they give you a set of instructions. This one is x comma y arrow x plus 4 comma y minus 3. So what that means is you're going to take all the x's and add 4 to them. So here the old x is negative 5, so if you add 4 to that you get negative 1. So negative 1 is the new x. And for b, the old x is negative 2. So if you add 4 to that, that gives you 2. So the new x is 2. And then here for c, the old x is 5. So if you add 4 to that, you get 9. So the new x is 9. So we took all these x's and added 4. And the reason we did that is because this said x and then x plus 4. Okay, then the instructions say to take the y's and subtract 3. So we're going to do that. So this y is 4, so the new y will be 1. And this y is 8, so the new y will be 5. And this y is 4, so subtract 3 from that, and you get 1. Okay, so here's the old A, the old B, and the old C. And then down here we have the new A, the new B, and the new C. And to specify that this is the new A, we put an A with a little tick mark above it. And then to specify that this is the new B, we put a new B and then a tick mark above it. And this is the new C, so we put C tick mark. Okay, so the tick marks just mean the new one. So now we're going to plot those points. So that's negative 1, 1. So there's the new A. And then this one is 2, 5. So there's the new B. And then this one is 9, 1. So there's the new C. So then connect those and you get the new triangle. Okay, so what we did was we took the old triangle and we translated it down to here. We slid it, but the fancy way to say that is we translated it. So the main topic today is translation. When you take an old figure and move it this way or another direction and get a new figure, and that's called a translation. Okay, so that was 13. It was just taking the old one and making a new one. So now for 14, it says, use the slope formula to see what direction the points moved in. Okay, so we're going to check to see this A went to here. So we want to see what slant it went on, what direction it went in. So what formula do we use? I mean, the question already said it, but what formula do you use to figure out the direction something's going in, or the slant? That's called the slope formula. Okay, so we're going to find out the slope between A and the new A. Okay, so it's been 4 or 5 days, but does anybody remember the slope formula? Yeah, Charlie?
Why? Because I know it's supposed to be.
Okay, good. That is a formula, and if you have it already, then you can look at that number to see what the slope is. That's good. But there's a way of finding what that m is. Yeah.
Y2 minus Y1.
Yes. Awesome. You subtract the y's and you subtract the x's. That's what he's trying to say. So we're going to do 4 minus 1, and then negative 5 minus negative 1. And 4 minus 1 comes out to 3. And negative 5 minus negative 1 comes out to negative 4. So that tells you that the slant is negative 3/4. So back in the picture, that means that the old A and the new A, the direction that you moved in to get there was negative 3/4. Okay, now we're going to check the direction from the old B to the new B. So that's the slope here. So 5 minus 8 and 2 minus negative 2. So I'm just doing y minus y and x minus x for slope. So 5 minus 8 comes out to negative 3, and 2 minus negative 2 comes out to 4. So that's also negative 3/4. So the point I'm trying to make is that the new A, the old A to the new A went on this slant, and the old B to the new B went on that same slant. So all the points are moving in the same direction, on the same slant. So that's what a translation does. It moves all the points in the same direction. Okay, so that was the idea behind number 14. Slope measures the slant or the direction, and so we found out that they're all moving in the same direction. Okay, now 15 says find AB and A prime B prime. So that's kind of disguised directions. What does it mean to find AB? Does it mean find the slope between A and B? You can tell by my tone of voice it doesn't mean that, right? It means find the distance between A and B. Okay, so what we're going to do is we're going to use distance formula now between A and B. Okay, so here's A, here's B. And for distance formula, you subtract, again, 8 minus 4 and negative 2 minus negative 5. So subtract the y's. And subtract the x's. Just like for the slope formula, you subtract y's and subtract x's for distance. But then after that, you square the answers and add them up. So this is the distance formula for figuring out how far it is from A to B. So you subtract and square and then add. Okay, so 8 minus 4 comes out to 4. And negative 2 minus negative 5 comes out to 3. And then 4 squared is 16. And 3 squared is 9. And then 16 plus 9 is 25. And then you take the square root to get rid of the square. So the final distance comes out to 5. Okay, so what that means is, back here over in our picture, from A to B, the distance is 5 centimeters or 5 inches or whatever those squares are worth. Okay, then the second part of the question says find the distance from A prime to B prime. So now we're going to go from this A prime to that B prime. So again, you subtract the y's, 5 minus 1 and 2 minus negative 1. What do you think this answer is going to come out to? It looks like it's the same size, right? When you take a figure and slide it down, it should be the same size. So that's what we're verifying now. We're trying to see if it actually comes out to the same size as the old one. So 5 minus 1 is 4. And 2 minus negative 1 is 3. And you can already tell it's going to come out to the same answer, right? Because this line looks identical to that line. So we're going to save ourselves some time, and now we know it's going to come out to 5 also. Okay, so this distance over here from A prime to B prime is also 5 centimeters. Okay, so again, the main topic today is translation. What we did is we took an old triangle and we moved it down here, we translated it down to here, and we got a new triangle. And all the points moved in the same direction. We verified that with the slope formula. And the new figure is exactly the same size as the old figure, because that's 5 centimeters and that's 5 centimeters. And we could check this one and see if it was the same as that one, and check that one to see if it's the same as that one. But you get the idea that this is exactly the same size as that. Okay, then for 16 it says measure the angles. So put a number 16 somewhere. You don't need much room for this one. And I'm not going to pass out protractors today, but when you measure an angle, you're looking for how big the rotation is, right? If you're here, how far you have to rotate to get up to there. So an angle is a rotation. So a protractor measures how much that rotation is, and we'll practice this later, but I'm just going to do them real quick to verify. Like this one here, this rotation is 40 degrees. So just label a 40 in that corner. So what do you think this one's going to be? 40 as well, right? Because if we slid everything down, not only should it be the same shape, or the same size, but it should also be the same shape. So I measure that one. Yeah, and that comes out to 40 also. Then I'll measure this one up here real quick. It's about 115. Verify that that one's the same. Yep, 115 also. This one is 35. Or sorry, 25. And this one is, yep, 25. Okay, so we just did number 16, so you can check that one off. Number 16 says measure all the angles. And the point of that was to show that these triangles are exactly the same shape. I mean, we measured the distance to find out that they were the same size, and now we measured the angles to find out they were the same shape. I mean, they were both triangles, right? But you could have triangles that were different shapes. So to be exactly the same shape, all the angles have to be the same. So that's why we measured the angles. So that these triangles are the same size and the same shape. Okay, so number 17 says, when you take a triangle and translate it, or any figure, when you take a figure and translate it from here down to here, what kind of a figure do you end up with? And it turns out you end up with a figure that is the same size and the same shape as the original. So the topic of the day is translation. What we did is we took a triangle. It could be any kind of figure, but the first one we took a triangle, and we just slid it down here. So we translated it. And when you do that, you end up with a new figure that's the same size and same shape as the original. That's called congruent. Okay, the other thing we figured out is that all the points moved in the same direction. They were all in the same slant. And it turns out they also move the same distance. Okay, so now we're going to go back to number 3, I think. Yes. And you do not need to write these points down, but I'm going to write them down quickly. T is at 3, -7, and W is at 7, -4. And then the new T is at 6, -9. And the new W is at 10, -6. And the question says, describe the translation using the correct notation. Okay, so let's look at the x's first. The x's went from 3 to 6 for the T, and they went from 7 to 10 for the W. So what's happening to the x's? Yeah, they're getting added by 3. Good. Okay, so the way you write that down is you say x comma y and then an arrow, and then x plus 3, and that x plus 3 means that all the x's got added by 3. So that went from 3 to 6, and that went from 7 to 10. So that's why we wrote x plus 3 here. So this is the rule, or the description of the translation. Okay, then for the y's, it went from -7 to -9, and from -4 to -6. So that's down 2. So that means the y's got subtracted by 2. So you write that down by saying y minus 2. Okay, so this question said, here are some points. Describe the translation using the correct notation. So here, this right here is called the description of the translation. Okay, this time they're giving us the rule. So you don't have to write this down. This is part of the question. The rule on number 4 is x comma y goes to x minus 4 and y plus 5. And then they gave us the new ones. So a prime was -8, 5, and b prime was 2, 7. And the question says, find the old ones. Okay, so this is all of the question. They gave us the rule. They gave us how it ended up. And our job is to figure out how it was originally. The original A and the original B. This is called the image, the new one. And this is called the pre-image, the original. Okay, so apparently the x's were subtracted by 4, right? So they already had subtracted by 4 to get the new one, to get the 2. So that means the original was 6. So this is weird because we're going backwards. They gave us the brand new one. That's why there's a prime by it. And so now, here the original was 6, and it got subtracted by 4, so now we have the new 2. Okay, let's move to -8. Something was subtracted by 4 to end up at -8. So that's -4. Because if you take -4 and subtract 4, then you end up at -8. Okay, so this one's a little bit tricky because we're going backwards. Is everybody doing okay? Okay, then the y's apparently got added by 5. And this one ended up being a 7. So the original one was 2. Because 2 plus 5 ends up at 7. And then this one got added by 5 and ended up being 5. So it's, yeah, exactly, it's 0. Okay, so this is called the pre-image, the old one, and this is called the image, the new one. And this problem was a little bit tricky because they gave us the new one and we had to work backwards to find the old one. Okay, last one I'm going to look at with you is number 5. And here they've got t at 3, -7. You don't have to write these points down. W at 7, -4. And y at 9, -8. And then they have the new t at -1, -2. The new w at 3, 1. And the new y at 3, 8. Make sure I get all those right. 3, -7, 7, -4, 9, -8, good. -1, -2, good. 3, 1, 3, 8. Okay. So there's some points. This is the pre-image and the image. And the question says, this is kind of interesting, this is not a valid translation. And the question is, why is it not a valid translation? Okay, Charlie?
Because y is totally different from t and w.
Like, what do you mean by totally different?
9, so you get from 3 to -1 is 4, and then you get 7 to 3 is also 4, but you get 9 to 3 is 6.
Okay, so here it's being subtracted by 4. Here it's being subtracted by 4. But here it's being subtracted by 6.
Yeah. And then,
So because of that, and oh yeah, the y's are messed up too?
yeah,
Go ahead.
And -7 to -2 is 5.
Adding 5.
Yeah, adding 5, and then -4 to 1 is adding 5, and then that one's
Adding is like 16 or something. Okay, so the answer is this is not a valid translation. Since for t and w, the x's are added by 4, but for y, or not added by 4, subtracted by 4, sorry. But for y, the y's are subtracted by 6. This is not a valid translation, since for t and w, the x's got subtracted by 4, but for y, the y's are subtracted by 6. Okay, so I'll pass that paper out in a minute, but first we've got a couple of note cards, just to get all this information down. Did I tell you the joke about the pizza yet?
no.
I don't think I should. It's too cheesy. How about the one about the skunk? The skunk. I'm not going to tell you that one either. Why? Why, Ethan? Because it stinks. Yeah, it's a bad joke. Okay, this is number 12 for note cards. And then the other one is number 13. And I want to write the title on number 13 first. They're coming. The topic of the day is the title for number 13. So that's translation. So we talked about a translation, and we're going to write some notes about that on note card 12. But a translation is when you take a figure and you just slide it somewhere else. And you end up with the exact same size and shape. You end up with a congruent figure. Okay, but the chapter topic, or the unit topic, is transformation. So that's the title for number 12. So a translation is a specific kind of transformation. Okay, so 12 is, a transformation is the process of moving each point of a figure by a given rule. process of moving each point of a figure by a given rule. And the one we had today is a translation, and that's when everything gets moved this way. But we're going to have other ones in the future, like for example, you could have a rotation, and that's when everything would get moved this way instead of this way. So that's a different type of transformation. Okay. And then for any transformation, the pre-image is the original figure. The pre-image is the original figure. And we use regular letters without tick marks for those. So that's called the pre-image. And over here, this triangle here, the A, the B, and the C, that was the pre-image. And then it got slid down to here, and that's the new one called the image. So the image is the new figure. And to tell apart between the old and the old we use just a capital letter, but for the new we put a tick mark on the capital letter. Okay, and then some transformations are rigid. And rigid means the new figure is the exact same size and shape as the old figure. And the fancy way to say same size and same shape is the word congruent. So maybe later we'll have a different kind of transformation where it doesn't end up the same size and shape, and it won't be rigid. But the translation was, because when we moved this down to here, it's the same exact size, because we measured, right, 5 centimeters, 5 centimeters, and it's the exact same shape, because we measured. All the angles were the same. So that's called congruent. Okay, so then today's transformation was called a translation, and this is also called a slide. And this is a rigid transformation. Meaning everything ended up the same size and the same shape. And the way you could tell it was a translation is there was a rule that went with it. And the rule looked like this. It was x comma y, and then an arrow. And then it said something like x plus 4 or something like that. So x plus a comma y plus b. So whenever you have a translation, this is the kind of rule that you're going to have. And then when you have a translation, points move in the same direction and the same distance. points move in the same direction and the same distance. So remember, we verified the direction with the slope. The slope formula told you the slant or the direction. And then we verified the distance with the distance formula, so you could see how far apart they are. All right, so I'll pass out the paper.